Sorting. Sorting is any process of arranging the elements either in ascending or in descending order. For example, during a class test, students submit their exam or papers to the teacher in a random way. Like sometime roll number 4 submit the paper, sometime roll number 10 submit the paper, and then it's 26 who came. After all the students submit the papers, teacher need to arrange them in ascending order of their roll number. Like roll number 1, 2, 3, 4, and so on. So this is sorting. Sorting is a process of arranging the elements in ascending. Generally we use ascending order. Array sorting is related to sorting element of the array. It changes position of the element so that the new array is a sorted one. So in arrays, when we do the sorting, we finally moves the elements. We interchange the elements so that when we find a new, when we complete the sorting, we get a new array that is a sorted one. Advantage of sorting: there are many operations that work more efficiently when there is a sorted array. For example, let's talk about a search called a binary search. In the last lecture, we have talked about linear search. Here we have a little introduction about the binary search. So binary search is a searching method. It searches the element in the array. But the requirement of binary search is that it need a sorted array. If you give a sorted array to a binary search, it can search the array of about 1000 elements in just 10 comparisons to find the element in. So if you give a big array of 1000 element and perform binary search, but the requirement of binary search is that it need a sorted array. So if you perform binary search on a sorted array, within 10 comparisons, it will tell you that the element is there in the list or not. Whereas on the same array, if you perform the linear search, it will need about 500 comparisons to search the array. Let's understand the situation. Here I'm just providing you 5 element array ARR 0, 1, 2, 3, 4. Before sorting, the array was 7, 2, 13, 1 and 5. And after sorting, it will become 1, 2, 5, 7 and 13. So the position of the array remains same, but the elements are interchanged. ARR 0 we get now 1, ARR 1 we have now 2, ARR 2 we have now 5. So finally the array get modified to get the sorted elements. So there are many methods of sorting available in the literature. Insertion sort, bubble sort, selection sort, quick sort, radix sort, bucket sort, merge sort, heap sort, and many more. So to arrange the element in ascending order or descending order, there are different methods. It is not the only one method we are studying. Today we are studying selection sort, the third number and third number. At third number we have a selection sort. So we are going to study selection sort, but it is not the only method. I have already listed about 8 methods here. There are different methods to sort a given array. Let's start with the selection sort. It is one of the simplest sorting algorithm. It divides the array into two parts. One is called sorted array and another is called unsorted array. Basically, this division is not physical division. It is just a logical division. The array remains same, but we logical divide it like here, from here onwards it is sorted array, and up to here it is sorted array, and after that there is unsorted array. So we logically divide the array into two parts. One is called sorted and another is called unsorted. At the starting, means during initialization, when the array just filled up from the elements, the sorted array is empty and unsorted array is the entire array. Before you start sorting, we assume that the sorted array is empty and rest all the elements are part of the unsorted array. Next, the smallest element of the array is selected from the unsorted array. We find the smallest element in the unsorted array because sorted array is empty, and interchange with the leftmost element, that is the first element. So as I told, sorted array is empty. So we search in the unsorted array. We find the smallest element. So when we find the smallest element after searching the entire list of sorted array, when I find the element, I interchange it. I swap it with the first element of the unsorted array. First or leftmost element. Right now at the starting, when I doing it first time, first element is the leftmost element. So I swap the leftmost element with the smallest element. Now the sorted array is of first element. Now we have one element in the sorted array, that is first element, and rest from second to last we have again unsorted array. Next point, we repeat the step of finding the smallest element from the unsorted array. Again we find the smallest element from the unsorted array and swap it or interchange it with the leftmost element. Now this first time, after first iteration, sorted array has the first element and the unsorted array is from second element to the last element. I am not talking about last element, maybe there are 100 elements. So you find the smallest element from second to 100 element, and you find that somewhere at 50 location there is the smallest element. Now you interchange that smallest element with the leftmost element, that is the second element. After this, the unsorted array will decrease its size and sorted array, that is on the left hand side, sorted array will increase its size by 1. Now there are two elements in the sorted array, right? Let's explain it with the help of a visual diagram. So in this example, we have a unsorted array of 8 elements. The elements are 14, 33, 27, 10, 35, 19, 42 and 44. We have an array of 8 elements. Now let's recall the first step. We divide the array into two parts like sorted and unsorted. So at the starting, the sorted array is empty and this all array is a unsorted part or unsorted array. Then the fourth step was to find the smallest element in the unsorted array. So let's find the smallest element in this array. We compare 14 with 33. Actually, to find the smallest element, what I have written here in English, red letters, that min equal to 14 and LOC equal to 0. I write min means minimum is equal to, I assume that first element is the smallest and its location is 0. Now from first element onwards, I will start finding the smallest element towards its right hand side. Like I compare 14 with 33. But 14 is smaller than 33, so that's okay. Again I find compare 14 with 27. I find 14 is already smaller than minimum than 27. Then next, then I compare 14 with 10. But here what happened? 10 is smaller than 14. As we are looking for smallest element in the array and 10 is smaller than 14, so min equal to 10. The value of min is now 10. At which location you find 10? 3. 14 is at location 0, 33 is at location 1, 27 is at location 2, 10 is at location 3. So minimum means smaller. Minimum element is 10 and LOC is 3. But still the searching in the list is not complete. As the search in the array is complete, you compare 10 with 35, 10 with 19, 10 with 42, 10 with 44. So I find that finally 10 is the smallest element in the unsorted array. Now I am going to interchange it with the leftmost element. The leftmost element is 14. So I am going to interchange 10 with 14. Let's read it. As search in the array is complete, interchange the smallest element with the first element. that is interchange the element with location LOC variable with the first location. Means you are going to change the element at LOC3 with the first location element. So after exchanging, what you find a sorted array of element 10, and all these element, rest of the element 33, 27, 14, 35, 19, 42, 40, 44 are part of the unsorted array. Now again, you repeat the same thing in the new array, that is array after swapping location. That is, you are again going to search the smallest element in the unsorted array. You start with 33. This new array 33 is the smallest, but when you compare with 27, you find that 27 is the smallest. But when you compare with 14, you find 14 is the smallest. When you compare with 35, again 14 is smallest. You compare in 19, 14 is smallest. 42, 14 is smallest. Comparing 14 with 44, 14 is smallest. So now you are going to interchange this 14 with the leftmost element of the unsorted array, that is 33. So here is the output. This top diagram is the output of that swapping. Now in this list you find the smallest. Very simply we can find out that 19 is the smallest. You are going to swap 19 with 27, and from the remaining list 27 is the smallest. You are going to swap 27 with the 33, and the remaining list you have find 33 is the smallest, going to swap 33 and 35, and the remaining list 35 and 42, 35 is the smallest. You are going to swap it with itself, again 42 with itself, and 44 with itself. So in this way, what we have done, we are going to swap the smallest element with the leftmost element in the unsorted array. This is the crux of selection sort algorithm. The selection sort algorithm is explained. So the name is selection sort. It needs two arguments. One is array and another is number of elements. So before calling the selection sort algorithm to work, you must provide the algorithm two things. One is array and another is number of elements. So repeat step 2 to 4 for I equal to 0 to n minus 2. So what happened, as you have seen in the last slide, we are comparing the element with its rightmost element. So suppose there were 8 elements. So n is the number of elements. Suppose it is 8. So the loop start from 0 to 8 minus 2, that is 6, because the location of the 8th element is 0 to 7. So we are moving this loop 0 to 6, because at 6th position we are going to compare 6 with 7. So always I need to go 2 steps behind the number of elements. Next is repeat for step j equal to I plus 1 to n minus 1. The loop for j is moving one step ahead the I loop. It's starting from I plus 1, that is it's starting from 1, and it's going to n minus 1. Suppose the number of elements is 8, so it's going up to 7. Next, find the smallest element along with its location in array. In j loop you are going to find the smallest element, and after the j loop ends you interchange the ARR I with ARR location. So whatever the location you have find, whatever the location of the smallest element you have find, you are going to swap it, you are going to interchange with the ARR I location. So I will always leave behind the j. So if I is 0, you find the smallest element in the array from 1 to n minus 1, and you are going to swap it with 0 location, and that's end of the first loop. Now I is 1, you are going to search the smallest element from j plus 1, that is 2 to n minus 1 location, and wherever you find the smallest element, you are going to swap it with 1. We will explain it more with more depth in the next lecture, where we explain the program for the selection sort. Thank you.